Since the dawn of civilization, man has been interested in devices which could assist him in simple arithmetical exercises. Among the earlier known machines or apparatuses are the abacus and the soroban. These use beads which are mounted on stiff wires and can be moved up and down or sidewise on them. They are used to count numbers. Still, you can find it in use in shops in Singapore, China, and Hong Kong. The next known advancements were the tabletop counting machine invented by Blaise Pascal, the French mathematician, physicist, inventor, writer, and theologian in 1664. Subsequently, the eminent German mathematician and philosopher Gottfried Leibniz invented the calculating machine in 1694, which could do all basic mathematical calculations such as addition, subtraction, multiplication, and division. In 1801, a Frenchman, Joseph-Marie Jacquard, introduced the concept of memory in the conventional weaving loom. Earlier, the workers had to memorize various designs or weaving patterns. The same information was now permanently held in a large-sized punched cards in terms of holes in the card. Herman Hollerith in USA extended Jacquard's principle of storing information on punched cards to other applications. In 1891, he redesigned the cards so that holes now correspond to statistical data concerning individuals. He also designed machines to punch the card and read data from it. These machines could perform the required additions to generate useful statistical information. Entire result of 1891 census was available in less than 2 years using Hollerith's machine, which could have otherwise taken 10 years' time using manual method. The company founded by Hollerith turned into IBM, that is International Business Machines, in due course of time. Charles Babbage, an eminent English mathematician, ventured to design a machine to solve simple polynomial equations. He named his machine as differential engine. This machine could solve various complex mathematical problems. The innovation of his design was that he incorporated memory into it, which he called store. The memory could hold output of all sub-calculations needed to reach the main answer. In 1930s, the technology advanced and ideas and concepts of Babbage was revived. In 1937, the American physicist Howard Aiken designed the first electromechanical computer at Harvard University. It used punched cards to supply the inputs and electrical relays to store data. Aiken's machine Mark I was used to generate tables for use by the artillery gunners of Army and also to solve equations for those who designed the first atom bomb. Almost at the same time, John Mauchly and J. Presper Eckert started working on the thermionic valve, that is vacuum tubes, version of the same machine in Pennsylvania University called ENIAC. Both the machines, Mark I and thermionic valve version, had a severe limitation, that is, to change the mathematical calculations, these required complete change in its circuitries, which was a very rigorous task indeed. John von Neumann suggested that all the detailed steps which the machine has to follow in performing a calculation, that is algorithm, should also be coded and entered into the machine along with the data. At the same time, Alan Turing, the English mathematician, also suggested a similar idea. And this was the major breakthrough, since the concept of a stored program provided a boom in the computing world. Von Neumann proposed that all arithmetical problems can be solved using binary notations instead of conventional units of tens. The ones and zeros used in this system was easily represented using electronic systems. Thus, the first computer was made using electronic systems instead of electromagnetic relays. It was known as EDVAC in USA and EDSAC in England. Later on, in 1948, an American physicist, William Bradford Shockley, invented the semiconductor device, that is, the transistors, which entirely replaced the thermionic valves. Thus, computers also started using the same, and its size got tremendously reduced due to smaller size of semiconductor devices, that is, the transistors. Nobel laureates Jack Kilby of Texas Instruments showed how an entire electronic circuit could be fabricated on surface of a silicon chip known as integrated circuits. This concept helped in miniaturizing the computer to its maximum. We will meet with the new AI topics in our next vlogs. Till then, keep your neurons active and keep watching. Friends, if you liked our blog and are benefited with the information given, then don't forget to subscribe it, like it and share it. Thank you very much.